Hi and welcome to this pre-learning video for measurement from the general math curriculum. And we're going to talk about Pythagoras Theorem in this video 1 for measurement. So we're reviewing Pythagoras Theorem. You should have seen it before. If you haven't, then you might want to go through in a bit more detail. There's some more in-depth videos on Pythagoras Theorem on my channel. But let's have a quick review. First of all, as best a right angle triangle as I can draw, here, Pythagoras Theorem states that the square of the hypotenuse, which we often call C, is equal to the sum of the squares of the two shorter sides. So remember that we have got some definitions here. C is called the hypotenuse, and the hypotenuse is the longest side. It also happens to be opposite that 90-degree angle. And interestingly here, it's opposite the largest angle, which makes it the largest side. 90 degrees has to be the largest angle because the sum of the angles in a triangle are 180. Leaving us those two that also add to 90, so neither of them can be greater than 90. So if it's a right angled triangle, then we have this situation. And of course, the relationship is that c squared equals a squared plus b squared. And don't forget that it could be written as a squared plus b squared equals c squared. And it could also be written as something else. You may call this d and this q and this capital T, and have q squared plus capital T squared equals d squared. The actual naming doesn't matter. What matters is the relationship between the longest side squared and the sum of the shortest two sides squared. That's Pythagoras Theorem. And that relationship means that we can find missing values when we're given the other two values. So that's the basic premise of Pythagoras Theorem. And I'll show you a really quick example, or a couple of examples, on how this works. So we'll start with the first example, which will be the simpler of our two examples. And we'll say that this side length here is 7, and this side length is 11, and we would like to find the length of that side. And remember, the first thing we have to confirm before we do Pythagoras Theorem is that this is indeed a right angle, which it is. And so we're going to calculate the length of that. And we know that a squared plus b squared equals c squared. And so while I'm learning, I'll be noting my diagrams A, B and C just to make sure I get it right. And that gives me 7 squared plus 11 squared equals C squared, which of course is 49 plus 121 equals, my apologies, C squared. And 49 plus 121 is 170 equals C squared. So C is equal to the square root of 170. And so we just do that calculation quickly. And we get 13.038448 ... and we can round that to 13.04. And whatever the units are, we don't have units here. And there is a second example I'd like to show you. And that is where we know the hypotenuse, but we don't know the other sides. This one's often considered slightly harder, but it's really just an addition of a little bit of rearranging. So let's say we know that this side length here is 12, and this side length is 2, and we're hoping to find this side length, which I'll call y. Not to skip out on tradition of using x and y, of course. So again, I'm going to label this A, B, and C. And the A and the B can be interchanged, they just have to be the two shorter sides. Start with my Pythagorean relationship and then substitute in my values. And this is where I have to be careful. A is y, B is 2, and C is 12. So I have to be really careful to make sure that I substitute in correctly, because it's a really common mistake to put A in as 2, B in as 12, and then calculate a wrong value. So that gives me y squared equals 12 squared minus 2 squared. 12 squared is 144, 2 squared is 4, that's equal to 140. And so now we calculate the square root of 140, and that comes out as 11.832159 ... and that's equal to 11.83 to 2 decimal places. So remember, I'm doing all my answers here to 2 decimal places, because actually on the front of your exam for the general curriculum, it will ask you to do this unless you're otherwise told. But it's always good to keep this value here as well. Maybe demonstrate that you know that value. It guarantees that you're going to get those full marks. And it also guarantees that if you have to do further work with the question, you've got enough accuracy to maintain the accuracy to 2 decimal places, which is good. Now, the only other thing in terms of the simple familiar you need to know for this particular topic is that you'll have to interpret some 3D diagrams. So I'm just going to quickly show you what that might look like. So here's a 3D shape. It's just going to be a cuboid, a rectangular prism. And if you want to draw a rectangular prism, I start by drawing a rectangle, and then I draw a second rectangle behind it, being mindful that some of it's going to have to be dotted. It's the same size rectangle directly behind. And then I can connect up the edges here, and look at that, a beautiful rectangular prism, if I don't say so myself. Now, we could determine the length of the diagonal from here to here using Pythagoras Theorem. This is a pretty common 3D Pythagoras Theorem question. So imagine you have a cardboard box. We could work out the longest stick or something that we can stick in that cardboard box. It's obviously not very efficient if you've got something filling a cardboard box but only along the diagonal. But the way we do it, and this is the hard bit to visualize, what makes this a bit tricky, is I'm going to do in pink first, I'm going to label some sides, A, B, C, and D. And by label sides, I mean these vertices. So that's the front face of my rectangular prism. And that front face is a rectangle, but if I draw this diagonal to here, you'll see that it creates 2 right-angled triangles. So what I could do is I could calculate from this side and this side, I could calculate length AC, which I'll call X. Now what I'm going to do is I'm going to visualize that AC actually connects along here to this side E. And I'm trying to find length AE, remember. So I've got some other value here. So let's say that we know that this is little a, this is little b, this is little c. I've worked out X using Pythagoras Theorem. And if I take that diagram out, I'll do this again in a different colour, so we'll take it out in green. Over to here, I've now got this triangle. Now this triangle is hidden in there, but I'll show you what the vertices are. A and E, and that's the side length we're trying to find, and this is C. Now if you look closely, it's like we're looking down from up here. And this is our length X, and this is our length C. And I strongly encourage you to just take a moment to visualize that, because that gives you an indication of how we could find that 3-dimensional length through a double application of Pythagoras Theorem. An application first to find X, and then an application to find the dotted blue line, or this question mark, in 2 right-angled triangles. Now in orange, I'm going to completely ruin this diagram and tell you there's another way that might be more visually appropriate here. And that is, if instead of looking at the front face, let's look at the base. What say I call this side length here, what am I up to? F, and I find this diagonal. So I've got ABF, triangle ABF, which looks like this. If I'm looking down from above, ABF, but then I can find AE by creating a second triangle, AEF. So now I'm looking sort of from in front, but on that angle there. And AEF looks like this. AFE, and this is what we're trying to find. Now this is length A. I haven't given this a name, so let's call it D. D, and then we can find this length here, which I'll call E because I'm just giving them letter names, so that's E there. That E is the same as AF over here, so that's E, and then this is length F up here, so we're looking at that length there, and then we can use Pythagoras again here, because a rectangular prism gives us a whole bunch of right-angled triangles. So it's a really quick discussion. I'm not going to go through and do an example of that. The 3-dimensional ones are tricky. They're complex, familiar questions typically, so we'll do some in class, but what I want you to understand is actually they're just basic level Pythagoras Theorem thrown into a pretty tricky to visualize context all the time. So if you can get past that interpretation and visualization, they're actually pretty easy questions for you to do. But people do find it hard to get past that interpretation. So there's our lead-in video for the first part of measurement. All the best.